Hello everyone, this is KP the Math G coming to you with a problem, a free response question 2001 question number 3. Now last time in the last video, which was my 147th video, actually all of these are AP Calculus based. So if you're taking AP Calculus and you want to look over these videos, you're welcome to look at any and all of them, because I do believe that this will be beneficial, especially when you're getting close to the end of the year now and you are getting ready to take that mock exam. I hope you take all of these tests very seriously, and that you take your instructor or teacher or whoever it is very seriously, whether this person is online or in a classroom. Please take this the rest of this year seriously. I just by my own personal experience of students, some are serious and some are not as serious as others, and I just hope that you are one of those. I trust that you're one of those serious students who really want to do well on this exam, or you wouldn't be watching this, right? Okay, well, let's look at the question. Question C is, and I'm out of room, I tell you, I'm just very much out of room here. For another spinning toy, the volume is 2 pi cubic inches. What's the value of C? I do know that when you plug a numerical value for C in, and the bigger C is, the more this arch is, the smaller it is, the less it is, and that's the idea behind C. So let's see here. Let's see, a keyword. We're looking for keywords. What's a keyword? And for another spinning toy, the volume. Yeah, volume. This is a volume of revolution, right? It's a volume of revolution. It's actually the area. Now remember, this is going to make a circular pattern when you are revolving this. And by the way, from the text itself, it is going to be about the x-axis. So this is what I believe to be called the disk method, not the shell method. So this is a solid, a revolution of solid, whatever you want to call it, method. So your isof interval will be something like this, and it's going to be always perpendicular to the line of revolution. Alright, so in this case it's the x-axis. Okay, so that's what we're doing. If we're doing it by this disk or solid revolution method, that's the way it's going to be set up. And incidentally, this is a radius r, which is, by the way, y. Well, y is this, isn't it? Alright, so what we have here is the area. Well, since this is making a circle, what's the area of a circle? Pi r squared. And then the area, well, actually it's going to be from A to B, so pi r squared. And then delta x, right? This is the thickness, alright? So delta x, alright? And again, we got to figure out what that is from A to B, what A is and what B is, which I do believe we can easily see what A is. A is going to be 0, but let's put it down here. Alright, so pi, we know what R is. R is y, so it's going to be all of this, cx times square root of 4 minus x squared. Alright, and then delta x, right? And that's actually delta x dx, delta x here. Alright, that's that thickness, and that's where you get your volume. And don't forget to put that square there, otherwise the whole thing is incorrect. Okay, pi r squared delta x, okay? And that's where you get volume from. Well, I know it's going to be in cubic inches. That's what the value of C is going to be here. All right. Now, I do know that this hypothetical interval moves from left to right if you want to. Anywhere you want to put it, you can start this at 0. But where does it end? What is this point right here? What is this point right there? Well, I do know if I call this A, then B, A comma B, has to be 0. This is actually x comma y, so y is 0. So if I set y equal to 0, well, let's erase this. Oops. Well, I've got another eraser. Okay. I may not have a lot of space, but I have plenty of erasers. Alright, so I'm going to set this equal to 0. Cx times the square root of 4 minus x squared. Anytime you're looking for the x value, especially if it's where it crosses the x-axis, y is going to be 0, right? Alright, so now this is either Cx is 0, which means that x is 0 when we're solving for x. And then we have the square root of 4 minus x squared also equal to 0. A times b, right? Alright, so it's this or that. And when I square both sides, I get 4 minus x squared is equal to 0. Then I can bring the negative x to the other side. So 4 is equal to x squared, which means that when I take the square root of both sides, I need to put it over here. 2, it's actually plus or minus 2 is equal to x. But now, since we're dealing with, since C is positive always, we're going to say positive 2. Alright, so we know that our limits of integration now are from 0 to 2. And that's really how you set this up right here. Is you got to find that limit of integration. They're not going to always give that to you. You just got to know to set y equal to 0 and solve for x rather. Okay, and then now I know that this is 2 comma 0. Alright, so now let's go ahead and do a little bit of algebra or arithmetic to this, cleaning up some stuff. Now this is c squared, x squared, right? Because when I square c, when I square x, right, that's what I get. And what happens when we square a square root? Okay, well, that's just that, whatever this is. So in this case, 4 minus x squared, this is just 4 minus x squared. Again, I will step to the side, write it a little bigger where you can see it. Alright, there's that. Just that underneath there, right? So now this is just 4 minus x squared dx. Okay. What I think I want to do here is set the c, since c is the constant here, and oh, by the way, this is equal to 2 pi, because it already tells us that the volume is equal to 2 pi. So I guess I should have done it here from the start. Right there we go. Alright, we're gonna do this problem on the other side. C squared x squared 4 minus x squared dx equals 2 pi. We'll see if I memorize all that. Let's see. Alright, so we got pi, and I think what I want to do is put c squared on the outside right here. We are going from 0 to 2, and then what did I say? That is, we have c squared x squared, now 4 minus x squared dx. Alright, because we took that square root off when we squared that. And I'm just going to distribute that x squared on both of those. So since c is a constant, you got to remember that c is a constant. So 4x squared minus X squared times x squared is x to the fourth and dx. Now, what method to choose? Alright, well, of course, this is what I would call the power method. You remember how when you first started doing definite integrals or even the indefinite integral, you had to increase your exponent by 1 and divide by that same exponent. So what we have here is pi c squared times, now we are going, excuse me here, we are going from 0 to 2, and remember, by the way, this is equal to 2 pi, so let's not forget the entire equation here. Alright, so now what we have, this is going to be 4x cubed over 3, right, minus x to the fifth over 5, right? Okay, now, of course, think about it. If I plug in 0, this is 4 times 0 cubed, which is 0, and 0 over 3 is 0, and 0 to the fifth is 0, and 0 over 5 is 0, so the 0 part's just going to be 0. So all we're really concerned about is just plugging the 2 in. So here we go, pi c squared times 4 times 2 cubed over 3 minus 2 to the fifth over 5. And then, of course, you want to put a big minus 0 right there. You can do that. Probably to show those the graders that you understand what this 0 here is. Remember, it is equal to 2 pi. Alright, we are solving for c, aren't we? Alright, so let's see. This is going to be, you know what I can do? Let's go ahead and figure this out inside here. 2 cubed is 8. 4 times 8 is 32. Alright, so pi times c squared times 32 over 3. Right? 4 times 8. And then 2 to the fifth is also 32. Now remember, this is not 0 because these denominators are different. Alright, right there. Might need to put those a little closer together, so to pi, what's it? Okay, pi. Now let's come up over here. I got to step around everything, it seems like. And we're going to finish our problem right here. So let's see, 32 over 3. Let's see, I've already figured that out. This is actually going to be, alright, so pi c squared. This is 160. If I multiply, this is going to be a common denominator of 15. So 5 times, if I do it right here, 5 times, you can actually multiply this by 5 and this by 3, and then this by 5 and this by 3, like that. So 32 times 5 is 160, so 160, and then of course 32 times 3 is 96, so minus 96, okay, divided by 15. Now remember, this is equal to 2 pi. I hope you can see all of that. We're getting close. You know what? I can divide both sides by pi, and I can just get this down to 2 right here. So c squared times, let's see, what is 160 minus 96? This is going to be, okay, I've got 64 right here over 15, okay, is equal to 2 now. Alright, so now to solve for this, I'm just going to flip this over. So c squared times times 64 over 15 times 15 over 64 is equal to 2 times 15 over 64. Alright, like that, and of course all of this divides out. So c squared is equal to 2 times 15 is 30. So 30 over 64, which is equal to 15 over, what is that, 32? 32. So that's c squared. But now remember, we're taking the square root of both sides. So let's see, we're running out of room here. C squared is equal to 15 over 32. So we're going to take the square root of both sides. So now c, and it's not plus or minus because c is positive always. So we're going to take the square root of 15 over 32. And whatever that turns out to be, but I'm just going to leave it at that. And by the way, in units, that is in cubic inches. Or you can just say inches cubed, but really okay. And make sure you put your units there like that. Alright, so there it is. The idea of being able to do a couple things here. First of all, recognize that this is a volume of revolution. And then this is, of course, this is pi r squared dx right there. There's your volume right there. It's equal to 2 pi. Where to get these from? Well, you knew this was 0. We already solved these. And anyway, we did this algebraically. We know this value is 2. So from 0 to 2. Now it's a matter of just doing the arithmetic and integrating. So once you do that, you just got to remember how to integrate this properly, and then plug the 2 and the 0 in there, and then solve, and you come up with C. Wow, what a problem this is. I'm kind of bending over a little bit because in the last video I got my head chopped off a little bit, so I'm trying to kind of stay crouched down a little bit. But anyway, I hope that you learned something from this and how to set up a volume of revolution, and then how to find well, from where to where, whatever you call that. Okay, and I just said it earlier, and sometimes I have a tendency to forget. But anyway, the limits of integration is what I meant to say. Okay, so, and then just doing the arithmetic from there, but just being able to set it up for one thing, that's what we got to be able to do here, right? All right, this is KP the Math G, getting ready to sign off. I appreciate every one of you who are tuning in, and I hope and trust that this has been beneficial to you. And you can watch any other videos. If you would like to hit that subscribe button, please do so, or click on subscribe. If you'd like to make a comment, please make a comment. Feel free to do that if you want to. And then if you would like to hit that like button, you notice every time I say that I'm already smiling. So yeah, hit that like button. Hope you hit the like button and not the unlike button, okay? The like button is really good. If you do hit unlike, then let me know in a comment what you didn't like about it, and I'll try to improve on it, right? So that's what my goal is for you, is to help you out. It's not about me. I'm not making any money off of this, but it's for you, okay? And that's what it's all about. So anyway, KP the Math G, ladies and gentlemen, have a great, great day.